nearly a full house.
Just a quick reminder, I think again, block 4 today. Tomorrow, room 4. The transition day, we'll have 8th graders and their parents in the building, starting at 1:30. Please keep that in mind as you're changing from block 3 to block 4. Also, seniors, you do not need to report to part-time or your advisor tomorrow, as you'll all be involved with the incoming freshmen and their parents. Freshmen, sophomore, and junior students, you will report to your Spartan time. 2 main goals of the day. You will do a year-end survey to give us some data to begin and make changes that are necessary next year, and you will receive your 2022-23 schedule once you show that your survey is complete. Please do not see the guidance staff tomorrow on your schedule, as they will be busy with transition day and the 8th grade student parents. Again, tomorrow, mandatory Spartan time for everybody, except for seniors. No great white board.
Well, for everyone who did not listen the other 30 times that I've said it in class, or the first day of class, or has ever read anything on our website and syllabus, reminder, today's your last quiz, 3 days of review, final. Said it how many times? 10% of your grade. Homework and notes, completion only. All of the notes, all of the homework, everything for the class. 10%. I usually don't even do that. It's 10% of, hey, look, you showed up and you did what you were supposed to do. Here's a freebie. That's it. 10% is your daily quiz at the beginning of every class. Looking at the scores, I know a good chunk of you are just BSing those, because there's no way you're getting 72 average on your tests, but always got a 5 out of 5 on your quizzes. That's a conversation you get to have with your parents when we say those are self-scored. 10% is the final. It's a border buster. That's it. Unless you've missed a whole lot of class, unless you didn't make it through first semester and now you need to show a certain level to get credit for the year, it is just 10%. Your final is literally going to be less than each one of your quizzes, because 70% are your regular tests. Well, this is the 6th one. That means every single one of those is 10 and what? 10 minus 6? 11.6-ish. So each one is about 11.5%. So your tests are actually where it's at, which is why they're open notes, why we review right before we do them. It's why I've done alternate assessment with some, I've done verbal assessment with some. That's why I have some kids come in and do review with me individually, because that's what really matters. Coming in and handing me like 3 things in here doesn't do any good. You're trying to push the car uphill by throwing a rock at the bumper. The tests are what really matter. You want to get a better grade? Do better on the tests. Been saying that all semester. You do better on the tests by doing things for real, by being engaged in class, by asking questions. We say this because A, we're at nearly the end, but B, You had 4 days in class, plus we also had 4 days, and in that time I only had one person bother to ask me anything about all of the word problem stuff, the review of basically what you're going to do right now. So I take that to mean either you don't give a flying fornication about it, or you're good. Either way, now it's time to put up or shut up. You have review. The first half of chapter 6 is all about the mechanics of it. Can you solve a system? Graph, substitution, elimination. The back half, now we're talking about 6.4, application. 6.5 and 6.6 were about the inequalities, which also included a good amount of word problems. It's not enough to just, I can jump through the hoops like a trained little monkey. It's, do I know why the hoops are there in the first place and what the point of this is? Okay. Let's see what we got. Number one is going to be straight out of 6.4. It is blah, blah, blah word problem. It's not going to fit any one specific form. It's just, here's words, figure it out. A really good thing to write next to that one would be my amount, or y, is rate x plus start. Sometimes we have slope-intercept form given to us in a problem. First hour is in that pile somewhere. Occasionally, we will get y minus a output, some sort of, oh, at this time this happened. In this year, this was the result. Rate x minus input. Okay. Occasionally we'll get those, not very often. And two variable systems, they absolutely love rate x plus rate y is total. Now with each of these, particularly these ones, remember that this tends to inform what the rest of the equation is about, because in a system you got two different equations. Well, if I have one total that's about money and another total that's about the number of shrunken heads, well then the stuff that has money in it all needs to be in the same equation. Put the rate for x that's got money in it with the total in that equation. Okay? Ducks go with ducks, oranges go with oranges, money with money. You put the label for the rates goes with the label for the total. They all match. So those were the three. This is all linear equations. We don't have to worry about anything too crazy. So read it and hunt for the magic words. What do you think? Okay, I do see a total. Before I go doing any sort of equation business, the very first thing you do, go to the question at the end. How many of each package of meat did you buy? So that's telling me what my variables are going to be. If you want to get fancy and label your variables according to whatever's in the problem, we're talking about what? Hot dogs and burger. If you want to call one H and one B. If you want to call one W for whiners and the other one H for hamburgers, okay? Whatever your jam is, most of us were just like, screw it, I'll just call it X and Y, okay? So if those are the two things that I have, I need to label next to them. We're going to have hot dogs and burger. I want to label that because when I go into my equation here, I need to make sure that I match the right rate with the right variable. So you said we got a total? You spend a total of, it even says the word total there. So I got 3162. It's in money. So that tells me the rates that go with these are in money. I need this much Y and this much X. So what's the money that goes with hot dogs? $1.89. What's the money that goes with burgers? Well, where's my other equation? Okay. You bought a grand total of 8 packages of meat. That's another total. Well, 8 is about just packages of meat. Did I have a rate that says there's always twice as many hot dogs as burgers? Since there's nothing like that, it is literally just this plus this. Hot dogs plus burgers is 8 packages total. And now you're off to the races. How do you want to solve it? I can do substitution or elimination. Okay. Substitution, because I got coefficients of 1. So right here, maybe I'll say minus y, getting x is negative y. You know what? Most of us probably want to say 8 minus y. Negative y plus 8, 8 minus y, same difference, right? If I said x is this stuff, I will now replace x with that stuff. So you go there, turning that into 189 by 8 minus y plus 519 y is 3162. If you need to grab a calculator, you go ahead and grab a calculator. Mental math, kind of sketchy. So what's that? $8, $1.60, $9.60, 72, 1032? What? Samsonite. 1512 minus $1.89y plus 519y is 3162. Some of us are dying without that Paxton line right there. And we ask, okay, again, I see so many kids make this error. I got kids, don't write this, who will add like that. What's wrong with that? Okay, that's why that line, that divider line through your equal sign can be very beneficial, is you just did the same thing twice to one side. What you do to one side, you do to the other. Okay? Instead, how about we combine like terms? Everywhere there's plus or minus, it's a new term, just like we're back in first semester. And you combine things that actually go together. We've got 1512, 519 minus $1.89. So what's that? 4, 3, 330? Okay. Play the who's lonely game. Who's lonely all by themselves on one side of the equation? Okay. He's lonely because he's lazy. Bring the date to him. Okay. It's a real good idea to show these steps. I don't care if you can do it in your head. I don't care if you can do it without writing that out. Every time you don't write something out, you're less accurate. I've seen so many kids miss a negative sign in front of that term all semester long across all classes. It's just a thing that we goof up. Okay, what we got? 50 through 16? Just 16, 50. You right there? You're his keeper if you want to just backhand him at any time. Beavis and Butthead style. Just divide. What do we got? I mean, we're talking about packages of hot dogs and packages of hamburger. Better come out as a whole number. Just 5. If you have an X, you better find out why. If you know why, then you should probably know who your X was. Plug it in. You can either put it in here, if you're really adventurous, up here. Doesn't matter. No matter what, you'll get X is 3. Answer the question. It's not enough to just have a bunch of math and then, look, I got numbers. Answer the question. How many of each package of meat did you have? Say, 3 packages of hot dogs and 5 packages of burger. Okay. When I look at these, step 1, did you write the equations correctly at all? Actually, that'll probably be 2, because if those 2 equations, if either one of them is off, it screws up the whole thing. Okay. Step 2 would be either substitution or elimination. Did you get to the first one? Did you get to the second one and then tell me what's up? Okay. Round 2. Different verse, but same as the first. This was a specific type of problem that we went through in section 6.4. They're super hard if you've never seen them before, but once you've seen them, it's like, oh, it's just the same thing every time. 12 miles an hour if you got the wind, 4 miles an hour if you're against the wind. Do we remember the setup for these? It's just plus or minus the wind. So label your variables. X and Y would be bird speed, wind speed. If the bird's going with the wind, then bird speed plus the wind speed is 12. If you're going against it, I mean, how many of you got the older sibling? The parents who pick on you, and they do that forehead palm thing, right? Where you try coming at them and they just check you right in the forehead and you're sitting there swinging at them, not being able to do anything. That wind is pushing that bird back, so it's the bird speed minus the wind speed. Substitution or elimination? That's set up perfectly for elimination. If I just add these 2 expressions, or these 2 equations together, 2x cancels 16. Divide, x is 8. Make a note to yourself. Tell yourself to finish, to solve it. Find both. So many times we get x equals number and we just quit because we're so used to, cool, I've hit the end. Like, no, there's more. Infomercial style. But wait, there's more. Go and put your 8 in here. And then answer the question. It's not enough to just get, here's numbers, I win. You have to say, the bird is 8 miles per hour. The wind is 4 miles per hour. Okay. Now, if you live in town here, you don't see it as bad, but you get outside of town, some of the wind around here gets pretty funky, being on the north end of the hills. It's just the way that elevation and temperature variation air masses work. I live outside of Bell, and I'm on top of a hill with no tree cover. Like, whoosh! I have seen a falcon in flight just sitting there. Just sitting there. Looks like he was just painted. Like, the dude's not moving. Okay? So 4 miles an hour might be anywhere but here. All right. Then we moved on to section 6.5. 6.5 was about linear inequalities. On the back side, I have the just, can you graph the things? Okay. I know you can graph the things. So I don't want a problem where we're just graphing one of them, because we're going to be graphing 2 of them in the other problems. Instead, how about the application of it? Because we ran across so many of these. You have 125 bucks to spend on school clothes, 20 bucks for a pair of pants, 15 bucks for a pair of shirts. Pair of shirts? A shirt. There we go. X is the number of pants you can buy. Y is the number of shirts you can buy. So you don't even have to write that. If you want to, you can, just to remind yourself so you don't have to go hunting through the text again. But they tell you what the variables are. Write and graph an inequality that describes a different number of pants and shirts you can buy. So they told us X is pants, Y is shirts, hunt through there. Where's my magic words? Do I have a rate? Do I have a start? Do I have a total? Okay, I got 2 rates and a total, so that tells me it's standard form, AX plus BY equals C. In this case, my total was 125. I've got this much Y, this much X. It said 20 bucks for a pair of pants, so the rate that goes with X, and 15 for a shirt, the rate that goes with Y. Be very, 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 very careful. You have 125 to spend. Are you going to spend exactly 125? If you've ever had that gift card from grandma, if you've ever been at the pump, you know getting the perfect amount is just, that's lottery ticket. It doesn't happen. But I can spend 125 exactly, so or equal to, but I need to be under that, not over it. I can't spend $128 if I only have 125. Ask yourself that question. Put that question next to this problem. Tell yourself, can I spend exactly this? Can I spend more than this or less than this? Or can it be more than this? Can it be less than this? Ask yourself that question and it will tell you your inequality. All right, so I've got the thing. How do I graph thing? I would do X and Y intercepts for sure, not just because it's going to be a little bit of a quicker graph, but also because it'll tell me how big to make my graph. I want to see the entire shaded region, so I need to see where it hits the X and Y axis. And I'm going to do that by, if I put a 0 in there, I get 15Y is 125. If I put a 0 in there, I get 20x is 125. divide my y-intercept was 125 divided by 15. It does not go in cleanly. Very close. 8 1/3. Thank you for going to Fraction Town. Okay. Hey. Okay. But so many kids are just like 0.33333333. They're like, no, be a big kid. Use fractions. 8 1/3. Or if you had said 25 thirds, right? Divide again. Very close. This one just terminating decimal. The reason I need to know those is I have to know if I need to change my scale. What if the x-intercept was 16 1/3, 6.25? I would need to change at least one of my scales. Okay? So we find our x and y intercepts so we know how big, and in this case, I can get away with just going by ones. So on my x-axis, x is number of pants, number of shirts for the y, and I can just go by ones. I can label every other because I'm lazy. Not lazy, I'm an effort economist. And when they say x and y intercepts are this and this, it makes the line super easy. Y-intercept is 8 1/3. Just make a dot at 8 1/3. X-intercept is 6.25. Make a dot at 6.25. Get a straight edge. Don't try to wing it. And connect the dots with what kind of line? Well, lines are straight, but yes, it is a solid line. Okay. How do I know which way to shade? I mean, just the context of the problem, if you know that I can't go past that many and I can't go past that many, has to shade this way. But the other way would be stick a 0 into both places and you get 0 is less than or equal to 125. If 0, 0 is a solution, that tells me everything that way is a solution. If everything that way is a solution, why is this only an L graph? Why doesn't it go all the way back like this? Yeah, you can't have -2 pairs of pants. You can't go buy -14 shirts. So that's why it's an L graph, is there's those hidden constraints of, nah, dude, also x is greater than 0, y is greater than 0. Now, I copy paste these out of a lot of old materials just to be sure. If I said, what are 3 different combinations of pants and shirts that you can buy? Would you be able to answer that? Anything shaded, go pick some points. Tell me you could buy 2 pairs of pants, 3 pairs, or 3 shirts. Tell me that you could buy 1 pair of pants, 6 shirts. Okay? If that's in the problem. I don't think it is, but also I forget things because ADHD go burr. Okay, so the word problem was on that part because on this side, this is where you get 2 of them. Now, I know there are some of you who still were in love with that shade a little, darken the living crap out of an area. If you're going to do that, make sure that I can tell the difference. I have to be able to tell where your answer is. If you're going to do the crosshatch pattern, if you're going to do it waffle style, I got to be able to tell where your answer is. But most of us picked up that just tiny little arrows was fine. So, first one, I can graph it by intercepts or I can rearrange it. It is purely your decision. I know there's a lot of us who really default back to that I want it in slope intercept form. So if I have negative 5x, here I'll just, negative 5x minus 2y greater than or equal to 4. If I want y by itself, who's got to move? Get y by itself. X got to get out of there. You see what I mean about zeroing that out and showing that there's a negative with it? That's a negative 2y greater than or equal to 5x plus 4. Why is that negative important? Because not only do I have to divide here and it's going to completely change the other side, but it also flips my inequality and changes which way I'm shading. When I divide this by negative 2 and this by negative 2 and this by negative 2, remember, math is communist. What you do for one, you do for all. Then I get y, negative 5 halves x, minus 2. But because I divided by a negative, I flop my inequality. All this goes back to, this is all first semester. Okay? So if you did very well or claim to do very well during first semester, that should be nothing for you. Start at negative 2, slope is negative 5 halves. Down 1, 2, 3, 4, 5 over 2. Or up 1, 2, 3, 4, 5 over 2. Up 1, 2, 3, 4, 5, back 2. Solid or dotted? Solid. More ink here means more ink there. Do it again, except maybe this time, see how they're all compatible numbers? 1 and 2 both go into 4. We'll just do this one by intercepts. If I put a 0 in there, I get x-intercept is negative 4. If I put a 0 in for x, I have 2y equals negative 4, divide and get negative 2. Mark those 2 points. X-intercept to negative 4, 1, 2, 3, 4. Y-intercept to negative 2. The more points, the merrier. I see a slope of right 4 down 2. Use it to make more points. If I go right 4 down 2, go right 4 down 2. Go right 4 down 2. Or up 2, back 4. Contestant 2, solid line or dotted? Less ink here, less ink there, dotted line. All right, shade time. Orange line. I can choose a coordinate trick. Usually we pick 0, 0 because it's nice and easy. Or if it's in slope-intercept form, this just said y is less than or equal to the line. So go to where the line hits the y-axis and shade down from there because y's are less down. Option 2, you put zeros into the original equation, you get 0 is greater than or equal to 4. Is that a true statement? Last I checked, being broke is not better than having $4. So instead of shading towards the 0, I will shade away from the 0. For contestant 2, again, I can put 0, 0 in there, getting 0 is greater than negative 4. Last time I checked, that's a true statement. So I would shade from the purple line towards the 0. Or if I had rearranged it, Nope, 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 nope. I'd have y is greater than a negative 1/2 x minus 2. I would see y is greater than the line. You shade where they're all pointing. Okay, all of my arrows are happy here. Okay, so we're going to have 2 of those to do. One of them is, I guarantee you that one of the 2 will end up just crossing like this, and it's one of the wedges. I guarantee you one of them will. The second one is a grab bag. Because what happens when I get this, and I say that? Where do I shade? Nowhere, right? That says stay above the line. That says below the line. Someone said you can only ride if you're this tall. Someone else said you can only ride if you're this old. You are neither. Well, crap, right? That would be a no solution. What if I had those same parallel lines and they did this? Everyone in between, right? That's where they're all happy. Really? Now you're going to pair everything? Stupid Frank, you redneck cross-eyed face. And I think we actually ran into this before. Okay. Mom says you can only date if you're 14 and older. Dad says you can only date if you're old enough to drive. Right? Like, if I have to meet this condition and this condition. Well, it's got to be both of them. So you shade everything above. Again, if you're going to shade 2 different areas, 3 different areas, and only one of them is the answer, please be sure I can tell what is what. So, that said, this one, they're either going to cross nicely or it's going to be a weirdo. Well, this one, almost identical to last time. I get negative x equals 4 and 2y equals 4 when I plug 0 in for y and 0 in for x, respectively. So graphing by intercepts, nice and easy. 1, 2, 3, 4. 1, 2. How do I get the rest of my line? I got a slope. I have a ratio there. Use it. If this went up to right 4, do it more. Up to right 4, up to right 4. Or down to left 4. I can also fall down the stairs. I have video proof. Okay. Solid line or dotted? More ink here, more ink there. You catching that pattern? It's the same thing. All right. So for yellow line, will I be shading above or below? Stick 0, 0 in there. 0 is less than 4, or less than or equal to 4. That is a true statement. So I will shade towards 0, 0 because it is a solution. If it's not, I shade the other way. So we'll go put some more air traffic controller arrows on there. This one's already in slope intercept form. That's nice. Start at -2, slope is up 1, right 2. If you have to say start y-axis, if you have to tell yourself up 1, right 2, like we're all the way back at the beginning of chapter 5, do it. Do what works for you. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Down 1 left 2, down 1 left 2, down 1 left 2. Solid or dotted? More ink here, more ink there. And that says y is greater than the line, bigger than, above. Or if I had plugged in 0, 0, it would be a true statement. I shade towards a 0. So we just talked about it. If all my arrows are pointing into the middle, shade the middle. And then, being the very last quiz of the year, thought it was only fair that we reviewed. This is taken directly off of your first quiz of the year. It's not enough to just memorize something for the next 2 weeks and then forget it. Because it keeps coming back and keeps coming back and keeps coming back. Dormammu, I have come to bargain. Okay? Can you translate words into math? Do you remember any of it? 91 more than the square of a number. What's the magic word in there that tells me what I'm doing with 91? Not just more. More means add, but more than. We pounded the living snot out of that first semester. If I say more than, less than, and it's not attached to is, am, was, were, are, those linking verbs. Linking verbs determine that this is going to be an inequality. There are no linking verbs next to it, so it's more than tells me I will add the 91 at the end of a thing. It is a direct translation from English to math. You just have to know how to translate. Okay, so 91 more than, yep, the square of a number. Do I know the number? Use a variable, okay, x. But how do I say the square of a number? Exponent. And as they're speaking about schedules for next year, that's actually how you're going to start next year. Meaning in August, when you come back, you're going to probably start with a tiny bit of systems to review all this stuff about equations and lines and stuff like that. Maybe 3 days or so is what the math department's kind of talking about. 3 days of review on systems, because that should refresh your memory on everything for equations and lines. And then you're going to jump straight into exponents. Turns out there's a crap ton of rules about them that you didn't know. You just know the definitions now. All right, what about the other way around? Turn math into words. Just like we used more than to put the 91 at the end, I'm going to say 10 less than to put the minus 10 at the end. Well, I can say a number times 4. What was the big kid word for times or multiply? Product. There you go. If you just say a number times 4, I'm okay with it. But we're reviewing, right? The product of a number and 4. Oh, if you just use D because it's there, that's fine. If you say 10 less than 4 times D. Maybe we can't just say times. Because if I say 10 less than 4 times D, The difference of a comma completely changes this. We talked about this in my class anyway, first semester. How does that change it?
It's the answer of 10 less than 4 times d.
It's like a set of parentheses. With that comma, that's 10 less than 4 times d. As opposed to, if I don't have the comma there, now it is 10 less than, okay, I'm going to put 10 after a thing, the thing is 4 times d, and that's fine. That's why we like to use the word product, because it's a little more formal and it squishes those together. Okay? But bringing things full circle, that was lesson 1, chapter 1. Did we remember it? Okay. So, devices over there, scramble yourselves up. Oh wait, no, you don't have to. We're already in seating chart. Although, yes, you're good.